Good morning. Hello. So I don't know if we can call ourselves lucky or unlucky. There was a nice snow out there now. Sun starts to shine. I think it's gonna melt. So we lost the school day. What you gotta do, you gotta watch this video, learn just a little bit of about rational functions. I'm going to show this video horizontal asymptote, that's the little thing left, and how can we draw the rational function so we can complete everything what we need to know for module 2. And these are my announcements for module 2, so please do remember them. All those WebAssign quizzes are due on Wednesday morning, right on the test morning. Obviously you cannot sit with your groups at this time, but there is an assignment that is going to be due. First time we're going to see each other on Monday, and I am requiring every group bring one paper, the group work, however you want to communicate each other during this time. So read the directions carefully, but to be able to do that group work perfectly well, you gotta watch this video. So I'm going to show you how to find the horizontal asymptote in a rational function and how also we can draw the rational function. All right, so there are a couple of cases to be able to find the horizontal asymptote of a rational function. Sorry for the scrap work here. All right, so horizontal asymptote is when x goes to infinity. So has horizontal asymptotes as x goes to infinity, where does f of x go to? All right, so then there are three cases. Case 1, numerator and denominator have an equal degree. Equal degrees. So then divide their leading coefficient. All right. So how that thing could be happening? Example, f of x is equal to x plus 5 times x minus 4 times x plus 2 divided by, hence on numerator I have a third degree, xxx, it's going to give us x cubed when we open it up, FOIL it out, and we don't have to do that, and never ever do that. And I have x minus 1, x plus 1, and let's say x minus 4. Let's say that I have 5 here. Okay, so this guy has a degree x cubed, then the horizontal asymptote will be y equals 5. So equal degree on numerator and denominator. It doesn't matter, it's x cubed, x squared, x. They need to have equal degrees. Divide their leading coefficient. It will be an equation because it's an asymptote. That will be y equals 5. Okay, case 2. What could happen? We could have a function that numerator has a higher degree than denominator. So numerator I have x cubed, denominator x squared. Then in this case there is no horizontal asymptote. There is a slant asymptote. Okay, we need to perform that division and get the equation of y, but we're not going to have a linear like y equals 5 or y equals 3 horizontal asymptote. It will not be horizontal anymore. It will be a slant. It will be a line. Okay, case 3. We could have a function. What could that be? Now the degree could be higher on the numerator. If I have a function like that, it's really hard. Right. Plus 1 minus 4. Now x plus 5 times x plus 2. So this is a second degree and this is a third degree. Now this time we do have a horizontal asymptote, and that is y equals 0. This was the horizontal asymptote here, case 1. case 3. And y equals 0 has another name, as you all know, that is x-axis. Okay, so that's the story with the horizontal asymptotes. So definition of the horizontal asymptote, as x values goes to 0, where do the f of x values go? So you start by checking denominators and numerators degrees. If they have equal degrees, you're not going to FOIL it out, you just check. So I have a first degree, first degree, first degree. If I multiply them, I'm going to have x cubed. And I have a gazillion other terms I'm not interested in. I'm just looking at the highest degree. That's x cubed on top. That's x cubed at the bottom. But look, I do have a coefficient 5. 5 over 1, that's 5. That will be my horizontal asymptote. Case 2, higher degree on numerator. There's no horizontal asymptote. We need to make that division, which is coming in module 3. Just write down know how. There is a slant asymptote. Why? Numerator has a higher degree than denominator. Case 3, denominator could be having a higher degree, then horizontal asymptote will be y equals 0. Okay, having that knowledge, let's go back to our rational function problem. So this is our rational function. We're going to go ahead and start it by finding the holes. Okay, so there is a hole, exact like terms. Then at x equals -1, we do have a hole. However, we need to write down this simplified version of the function, which will be 2 times x minus 6 okay, all over x minus 3. Okay, so in that simplified version, I'm going to plug in -1 so then I can figure out the y value of the whole. 2 times -1, -6, all over -1, -3. So simplified version of -1, that will be -7, -14 over -4, right? So that will be 7 over 2. So we do have a whole answer at -1 and 7 over 2. Okay, but we need to know or keep that in mind to be able to figure out the domain. All right, determine the vertical asymptote. Vertical asymptote, we're looking up here, right? So x minus 3 cannot be equal to 0. X cannot be equal to 3. That's why x equals 3 is the VA. That's the answer. Okay, so we know these two red circles. Now we can decide the domain. So in the domain, we cannot have -1, we cannot have 3. So then domain will be -infinity, -1, union -1 to 3, union 3 to positive infinity. This is the answer. Let's put the check marks next to it. Now, horizontal asymptote. For horizontal asymptote, we're going to go back and look at the original function. All right. Because we did have a simplification, things might be different. So I would suggest go back your original function. And in our original function, we were having f of x is equal to 2 times x minus 6 times x plus 1 all over x plus 1 all over x minus 3. Okay, so here I have a second degree, which is x squared. Here I have a second degree x squared. So the degrees are the same. Now I'm going to do a division of their leading coefficients, which is 2. And there is a hidden 1 here. So then that will be my horizontal asymptote. Horizontal asymptote is an equation of a line. So y equals 1 is a horizontal asymptote. And that's the answer. Okay. X-intercepts. X-intercepts are coming where the numerator is equal to 0 on the simplified version. So simplified version, we have x minus 6. So x minus 6 is equal to 0, x equals to 6. Then x-intercept is 6, 0. Y-intercepts are where x equals to 0, what's the y value? We can do that with the simplified version again. So I'm going to plug in 0 for simplified version of x, which is 2 times 0 minus 6 divided by 0 minus 3. So that will be negative 12 over negative 3. That will be 4. And that will be the y-intercept. Okay, so we're going to get all those points together and draw the graph. All right, so x-intercept, when x is 6, y is 0. Y-intercept, when x is 0, y is 4. Okay, and we do have a hole. Hole is at negative 1, 7 over 2. So that's negative 1, and 7 over 2 is 3.5. So it should be somewhere here. You have a hole there. All right, so we need to put the vertical and horizontal asymptotes. That's one of the benefits of y equals 1, horizontal asymptote. Horizontal line. Okay, vertical asymptote was x equals 3. Okay, so as you see, I have points on the second quadrant and I have points on the fourth quadrant. So it means that I'm not going to be using these quadrants. So I will be drawing my graph, making sure that I am passing these points and using my asymptotes. Oop. Something like that. It's not the state of the art, but it works. All right. So you don't have to put the cross marks there. That's train of thought. So that will be the rational function. Hope this helps. See you on Monday. Happy studying.